Welcome to the YouTube channel Physics Theories and Numericals, where we are providing you high quality videos for easy and joyful understanding of physics theories and concepts of life. Once you understand the theories, handling of numericals will be easy. Also welcome to the easy solution series of videos for ICSE class 10 physics. Here in this easy solution series we are providing you the solutions to the numericals under exercise for Selina Concise physics book, the most popular book for ICSE. This video is for current electricity chapter exercise 8a. The first numerical, it says in a conductor 6.25 into 10 to the power 16 electrons flow from its end A to B in 2 seconds. Find the current flowing through the conductor. The charge of electron has been given as 1.6 into 10 to the power minus 19 coulomb. You need to find out the current. Number of electrons flowing in 2 seconds have been given. This is the solution. The solution is you need to find out total charge flowing. You have given the number of electrons, that multiplied by the charge per electron. You multiply that, you get the value in coulomb. So that value of charge is flowing in 2 seconds. So current is I is equal to Q by T. So you divide that charge by 2 seconds. So you get 5 into 10 to the power minus 3 coulomb. That much of charge flowing per second, that is 5 milliampere. So answer is 5 milliampere, and again it says electron flowing from A to B. That means current is in opposite direction of flow of electron. So current is flowing from B to A. Next numerical. A current of 1.6 milliampere flows through a conductor. Current has been given. If the charge of an electron is given, find the number of electrons that will pass each second through the cross section of the conductor. Here current has been given, charge of electron has been given, you need to find out the number of electrons flowing. So easy one. So current has been given. So you know that Q is equal to N into E. Q is the charge flowing, N is the number of electron, E is the charge of electron. So N will be Q by E. You just divide that, so you get the answer. So answer is 10 to the power 16 number of electrons flowing per second. Next MCQ. Find the potential difference required to flow a current of 200 milliampere in a wire with resistance 20 ohm. A very easy standard or simple formula, Ohm's law, V is equal to IR. So you have been given I, you have been given R, multiply that, you get the value of V. So V is 4 volt. An electric bulb draws 1.2 ampere current at 6 volt. Find the resistance. So current has been given, voltage has been given. You need to find the resistance. Let's see the solution. Easy one again, as per Coulomb's law, V is equal to IR. So you need to find R. So I is equal to V by I. So you divide 6 by 1.2, you get 5 ohm as the resistor. Resistance of the resistor. Next one. A car bulb connected to 12 volt battery draws 2 ampere current when glowing. What is the resistance of the filament of the bulb? Will the resistance be more or less when the bulb is not glowing? So again, simple one. V is equal to IR. From that you get R. R is equal to V by I. You have been given V, you have been given I. So you get the value of R just by dividing that. Now, when there is current flowing, that flow of current generates heat. So when current flowing, resistance will be higher. That means when the current is not flowing, then resistance will be less. Next one. Calculate the current flowing through a wire of resistance 5 ohm when connected to a battery of potential 3 volt. Easiest one. So Ohm's law again, V is equal to IR. You have been given resistance, you have been given voltage, you need to find current. So V by R, 0.6 ampere. Yes, this is a nice one. In an experiment of verification of Ohm's law, following observations were obtained. So voltage and current, that table has been given. Draw VI graph. That means you need to draw voltage versus current. So current is independent variable here. That means you are varying current and you are getting the voltage. So you need to draw the VI graph. You need to find out the potential when the potential V when the current is 0.5 from that graph, and you need to find out current when the potential difference is 0.75, and you need to find out the resistance of the circuit. So first you need to draw the graph, VI graph. So first you need to take a graph paper and you need to scale them. Here I will be in the x-axis, current will be in the x-axis, because you need to draw a VI graph. That means you will be getting the value of V for different values of current. So current will be in the x-axis. So the first important job is to scale the graph paper. So you put the value, your total maximum current is 1 ampere. So you try to match that graph sheet for 1 ampere maximum value. So you put the values of current, then you need to scale the voltage side. That means y-axis you need to scale. So in y-axis also you put the values. So you make the entire scale 0 to 2.5 and put the values in between. So you got the graph sheet. Now you need to put the points, you need to plot the points. So what are the points? For 0.2 ampere, 0.5 volt. For 0.4 ampere, 1 volt. For 0.6, 1.5 volt. For 0.8 ampere, 2 volt. And for 1 volt, it is 2.5 volt. For 1 ampere, it is 2.5 volt. So you put the dots on the graphs. These are the 5 values, 5 dots have been put. Now you need to join them. So join them with a line. We have been given 5 dots, we have joined 5 lines. So it should go through 0, 0 also, but that we have not drawn because that value has not been given. We have been given 5 values, we have drawn the line appropriately. We have not extended it in any side. Okay, so now you got the graph. So you see, it's a straight line graph. That means it's a ohmic resistance. It's a straight line graph. Now you need to get answer to the other questions. You got the graph. What are the other questions? First one, it says you need to find out the potential difference V when the current is 0.5 ampere. So on the current scale, you look at 0.5. You got 0.5. From that, you move upward, reach the graph. So you reach the point A. You moved from 0.5 ampere, you moved upward, came on the graph, you located point A. From point A, you again move towards y-axis. So you reach y-axis, find the value where you reached on the y-axis. That value is 1.25 volt. That means answer to question number A is 1.25 volt. Similarly, when the voltage is 0.75 volt, so first you locate 0.75 volt on the y-axis. So you got the point, then you move towards the graph. So you reach point B. From point B, you move downward towards current axis. So where you reach, that is the value of the current, that is 0.3 ampere. So answer to the question B is 0.3 ampere. Now you need to find the value of the resistance. Now you know resistance is del V by del I. So on the graph you take 2 points P and Q. You join them. You get the value of del V. Here it is 2 volt minus 1 volt, that is 1 volt. And what is del I? That is 0.8 minus 0.4, that is 0.4 volt. So from that you find the value of resistance R is equal to del V by del I, that is 1 by 0.4, that is 2.5 ohm. So you go step by step, follow the process, you will get the answer. Hope you are liking this video the way we are solving the questions in a very easy style. Please subscribe to the channel, like, share and comment on the video and press the bell icon. Let's go to the next one. Two wires of same material and same length have radii 1 mm and 2 mm respectively. You need to compare their resistance and their specific resistance. Again, easy one. So it is same material. That means specific resistance or resistivity, that is rho value, will be same. So the ratio of the resistances are 1:1. Specific of the resistivity, ratio of the specific resistance is 1:1. Now answer to question number 1, their resistances. So we know resistance is rho L by A. You need to find out the ratios. So find the ratio of the lengths. Length is same. So length ratio is 1:1. Find the ratio of the areas. That is, you have been given the radii. So the ratio of the areas are A1 by A2 will be pi 1 square by pi 2 square. You don't need to convert the unit because it will get cancelled. It is in millimeter. When you need to find out the value, you need to convert that into meter or so. But here you don't need to, because you are finding out a ratio. So ratio will be pi 1 square by pi 2 square, that is 1:4. So now you got all the ratios. So R1 by R2 will be rho 1 L1 by 1 divided by rho 2 L2 by A2. See, rho 1 L1 and rho 2 L2 will get cancelled because that is 1:1. So finally it will become A2 by A1, that is 4:1. Easy one. Go step by step. Use your fundamentals. Go through the formula that you know. Next one, question number 9. A given wire of resistance 1 ohm is stretched to double its length. What will be the new resistance? This is the solution. It is stretched. Stretch means volume remains unchanged. That means if length has become two times, the area will become half, because length into volume will give you length into area will give you the volume. So if length has become double, area must have become half. So new resistance will be rho L by A, L becoming 2L and A becoming A by 2. So new resistance will be 4 times, that is 4 ohm. Next one, number 10. A wire of resistance 3 ohm and length 10 centimeter is stretched to length 30 centimeters. Same question. It has become 3 times here. Assuming that it has uniform cross section, what will be the new resistance? Again, same thing. It has become, length has become 3 times. That means area has become 1/3. So new resistance will be 9 times. So it will be 3 multiplied by 9, that is 27 ohm. So go by the fundamental. Go by the formula that you know. R is equal to rho L by A, V is equal to IR. These are the basic formula that you need to keep in mind. You need to find out the values. You need to put them into the value, get the required value. Next one, number 11. A wire of resistance 9 ohm is having length 30 centimeter is tripled on itself. What is the new resistance? What is tripled? Tripled means it has made three-folded. That means it has made three-folded and the ends are joined. That means one part becomes 1/3. It has become threefold. So one small part becomes 3 ohm, because total length is 9 ohm. One small part is 1/3 of that. It will be 3 ohm. And then it is put in parallel. That means 3 ohms put in parallel. So it will become 1 ohm. Next one. What length of copper wire of specific resistance given and radius 1 millimeter is required to make it resistance 1 ohm? Very easy, simple formula, same formula. R is equal to rho L by A. Let's see the solution. R is equal to rho L by A. What is A? A is pi into R square. Here you need to put the value of R in meter. So put the values, put the value of rho, put the value of resistance, that is 1 ohm. Only L is unknown. Be careful that you need to put the value of R in meter, because your resistivity or specific resistance has been given in ohm per meter. That means you need to convert that 1 mm into 1 meter, that is 0.001. So put the value, be careful in doing the calculation, you get the value of L. The L is 184.87 meter, that is almost 185 meter. How much is 185 meter? It is length of 2 football ground, approximately 2 football ground length. Okay. Next one, the last numerical of the exercise. The filament of a bulb takes 100 milliampere when the potential difference across it is 0.2 volt, and when the potential difference across it becomes 1 volt, the current becomes 400 milliampere. You need to calculate the resistance of the filament in two cases, in each cases, and account for the difference. So this filament, bulb, glowing switch, all these are stories. You don't need to focus on that. You find out your required quantity values, voltage, current, resistance. You find out your required quantities. So here, for the first case, the resistance is 0.2 volt by 100 milliampere. That is 2 ohm. For the second case, again divide voltage by current. So you get the value of the second resistance, 2.5 ohm. These are the two resistance of two cases. Now flow of current generates heat, so that will raise the temperature. So the resistance has gone up because the temperature of the resistance has increased. Hope you like the video. The way we have explained the numericals, you must have found it very easy. Please subscribe to the channel. We will be coming up with the solution for the subsequent chapters also. Thank you for watching this video. Bye bye till we come back with the next video. See you.